Welcome to today's session, which is about one of the most trending topic in tech world right now, which is about machine learning. So we have just concluded our session, which was about statistics. Now we are going to start with machine learning, and this is the day one of this machine learning community session series. So let me introduce myself, guys. I'm Giant Samarosa. I'm currently studying in Brack University, and this is my third year. So without any further ado, let's get started. In today's session, the things that we're going to be talking about is what is machine learning, the real world application of machine learning, types of machine learning, and we're also going to be talking about the workflow of machine learning, some terminology in machine learning that is used in the tech world. Then we will have a question and answer session. So, since this is a beginner friendly session, I don't want to quickly jump into the technical terms. Firstly, I want to go through the real life application and I want to share a little story where I found my intuition about machine learning. So, let's do that. Okay, so one day, me and my friend went to New Market. And if you're not from Bangladesh, maybe you don't know what is New Market. So New Market is a place where you can find literally everything with the cheapest price. But you have to bargain a lot. And if you don't bargain a lot, maybe you will be asked a very high price. So me and my friend went there to buy some fabric for myself because I wanted to make a cloth. I wanted to make a dress. And I wasn't really sure about the price, how much it will be costing. So I was pretty nervous since they ask very high range of price. But me and my friend went there. Then firstly we went to a store. We asked a price and they asked very high amount of price to us. Then we were like, okay, we have to move to the next stores and we have to find some other stores and see what other stores are offering. Then we went some other stores and finally after moving to other stores and knowing what type of price they are charging, we finally chose a store and we bought our piece of fabric from there. And yeah, that was it. But the thing that hit my mind that hey, isn't it is like a machine learning algorithm? I mean, isn't it similar to machine learning? Okay, let me break it down to you. So, uh, firstly, since me and my friend went there, uh, we went to several stores. So, by going to several stores, we collected data, right? That how much the fabric might cost. They were charging us very high. We collected some data. Then, after moving to 5 or 6 stores, we had a pretty much idea or prediction that how much that fabric should cost. Maybe it should cost 300, but the other shop owners were charging us 600. They were asking a lot of money. So after moving through 5 or 6 stores, we finally come to a conclusion that okay, we want to buy it within 250 taka, right? So firstly, we went to different stores. We collected data. After that, let me explain these things. Uh, yeah. So, just as I said, we collected some data, then we trained and evaluated our model. So, in this case, we are not model, right? But we can think of our brain like a model. Firstly, when after going to several stores, when we have idea, so we have some sort of uh, we could crack the pattern that how much the fabric should cost, or we could find the pattern or idea that how much it should cost. And after that predicted value. After that, we finally come to a conclusion. Okay, we want to buy it within 250 taka, which was our predicted value after going through all these stores. So in machine learning, you will see. Just a second, guys. Okay. For some reason, my graphics tab isn't working. Just a second, please. Right. So in machine learning world, we see that we give some input to our model and we get some output. And the output is basically it can be a it can be a prediction, it can be a binary answer. Mostly it is a prediction. It is a predicted value that the model gives us. And in this part, suppose you can think it as a function like f of x equals to y. So in this case, your x is the input, whatever the value you're putting. In that case, in our case, what value we were putting? The value we were putting was the price for that particular size of float, right? So that was our input. That we were inputting some prices that fabric should be in, and our output was a prediction that how much it should be cost. So in machine learning, we always have input and we always have an output, which is the prediction that the model is giving. And you know what? In this model, we will see different kind of algorithm: linear regression, logistic regression, SVM, decision tree, different type of model, and we will get an output for input. So this is the very basic idea of machine learning. You can say this is a basic intuition. We will dive deeper, but yeah. So basically, it is input to output mapping, right? So we can see ML application in real world. Um, let's talk about Siri or Alexa. You ask, "Hey Siri, what is the weather of today?" Siri answers. Then we can see that in our Gmail account we have a part where we can see where all the spam emails are stored. Then when you suppose you are action freak, you love action movies, and Netflix automatically suggests you action movies. So how does do it? Then in your Google Photos, you see this, right? That they identify whether the person is same or not. So all this application are done by machine learning algorithms. Then you can also see house price prediction. It is almost similar to the story I was telling you, that we predicted price. We had some input, and by that we predicted some price. So in house price prediction, you might have house size, room number as your x value or input, and for output you will get price. So this is also a example of machine learning application. Then you can also see machine learning distinguish between animals or two categorical values, such as here we can see cat or dog. So machine learning can uh, differentiate between cat and dog, and all these things can be done using machine learning algorithms. Moving forward, so just like I said, machine learning is all about input to output, right? So here are some cases. Suppose in your x value, and in your x value, gets email, and it will tell whether it is a spam or not. So in this type of application are called spam filtering. Then you can also give your audio, and it will convert to text transcription, speech recognition. Then suppose you are in a different country, you don't know the Spanish, so you say some words in English, say your whatever you want to tell in English, your machine's translation translates into the Spanish. Then you can also see that when you uses, suppose you use Daraz or you use Food Panda, uh, they always give you ads, right? And these ads are generated whether you will buy it or not. And all this application, again, it is the application of machine learning. So whether you will click in that ad or not is the output in this case. And this type of application is called online advertising. Then again, you have another two: self-driving car, visual inspection, again machine learning application. Now I have a question for you: can we consider calculator as an machine learning model example? What do you guys think? Can we consider calculator as an machine learning model example?
No, I guess.
All right. Anyone else? Do you want to say anything other than no? Anyone? All right. I'll take that. Just a second, please. Yes. So my question was, can we consider calculator as a ML model example? Yes. So you said that we cannot, and yes, correct. Answer was actually correct. We cannot consider calculator as a machine learning algorithm. Look, calculator also takes some value as input, and also it produces some value as output. But the thing why you cannot tell that calculator is a machine learning model, because it has no learning. And calculators are explicitly programmed. Suppose you have a case where your calculator can only let's say your calculator can only do calculation with polynomial degree of 2. And if you want to give your input in polynomial degree of 4, your calculator won't be able to produce any answer, right? Because it is not trained as that way. It is not programmed as that way. But your machine learning algorithm, it has something. It has its own capability to learn the data that you have given, to learn from the data, gather experience, find some pattern, and after that it gives a output. So there will be cases where you do not explicitly program your algorithm, but you will get some prediction which you cannot see in your calculator. So yeah, you're right. Calculator is not an example of machine learning model. And just you have said here, like, look, you put some data, you're a human, you're a traditional programmer, suppose you're a software engineer, uh, you made what can I say? You made a front end page for your project, right? So it is explicitly programmed that way. But um, okay, that is not a really good example. But in what I'm trying to say, that the machine learning algorithm, it will be able to produce some different answers or different prediction from the values or data that that model has never seen before, right? So that was the main takeaway from this part, that machine learning models are not explicitly programmed, just our traditional applications are. So yeah. So after this intuition, we are finally here. What is machine learning? You know why I have kept this slide after all this slide? Because I want you guys to build that intuition um, after seeing the real life application, sharing my story. Yeah, that was a pretty funny story, but clearing your intuition and building your intuition. And now we are here for a formal definition of what is machine learning. So machine learning is a branch of artificial intelligence. You can say it is a subset of artificial intelligence that focus on giving machines the capability to autonomously learn from data and past experience. You remember the story that I told you that I went with my friend to New Market, and in that case, we learned from our data and past experience. We learned how much the other stores are charging. So after getting all this data, building our intuition, okay, so maybe they're charging 400. Okay, let's move to the next store. Maybe they can charge a little lesser. Maybe they're charging 300. Okay, so after getting all this data, we have this pattern, and with that pattern, we can give a prediction. So this enables them to recognize patterns and make prediction without being explicitly programmed. Explicitly programmed, the calculator example, right? So I hope you guys are clear till now. If you have any question, please ask me. All clear? Uh, may I go forward? If you have any question, you can unmute yourself and ask me.
All good.
All right. Moving to the next part. Now, since we have learned just what is machine learning, now let's talk about different types of machine learning. We have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Okay, we will get into all of those one by one. Okay, so why I have kept this slide here to make you understand the main difference between supervised learning and unsupervised learning. You see, in supervised learning, we have some X which we will call, okay, before that, let me just talk about the terminology in machine learning. What is label, what is feature, what is prediction, okay? All right, so our input is known as feature, and our output, it is known as label. And uh, the prediction that we will have, it is known as, it is symbolized with this letter, and it is known as prediction variable. So you can also call this Y as target. It might seem a bit confusing at first, but trust the process. I will make things easier for you. And so this is Y, this is X, Y. Just think of the function that we have already studied in our mathematics classes, fx equal to y. So, you know, this is the input, which we call feature. You can have multiple feature or one feature is also okay. And in y, this is called as label or target. And the value that we're predicting, that is prediction variable. So, and m, you will see the m in, not today, in the next sessions. So the n is number of training example. Okay, number of training example, we usually get our data set and we divide it into a ratio. We keep our 80% of data for training and 20% data for testing. So you see the M, it is a training example, the numbers of data that you will be keeping for your training model, you know. So that was almost some basic terminology of machine learning. You will call your input as feature, you will call your uh, output label or target, and this is your prediction variable. So yeah, okay. So in supervised learning, we do have a label, but in unsupervised learning, we don't have a label. And I will talk about that. What is a label and how does it actually, make sense? Then in supervised learning, we have regression, we have classification. In unsupervised learning, we have clustering. In classification, we have binary classification, multi-class classification, so on and so forth. We also have a lot of models over here, which we will be looking at the next slide. Okay, so the main intuition behind supervised learning, that the training is done using labeled data, right? Features, there can be multiple features, as I told you. You see, x1, x2, dot 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 to xn, and there will be one label. Okay, so now to make things easier for you, I will give you some example for supervised learning. We will talk about how regression is different from classification, and to give you a basic intuition, we will get into a lot of examples. And the things you are seeing here, these are all the models, all algorithms. By using all these algorithms, we can perform our machine learning problem. Okay, so now we will quickly see some supervised linear uh, examples, right? So, okay. So, supervised learning, what is the main intuition? That it will have labeled data. This is the main differentiation between supervised learning and unsupervised learning. So, suppose, actually not suppose, this is summer and we are all dying out of this scorching heat, right? So, think that you are thinking of a business and you need to predict that in which temperature, in how much temperature, how much ice cream, the number of ice cream will be sold. So you want to find the number of ice cream sold, and you will calculate the number of ice cream sold by looking at the temperature of that day. So, suppose you and your friend started your business and you have collected a lot of data to predict in which temperature the number of ice cream will be, what will be the number of ice cream. So, okay. So, in this case, the temperature is our feature and the number of ice cream that we want to predict is our label or target. I think target makes more sense, right? Uh, yes. So you can draw a graph like that, and in this part, we are taking the, since it is the x value and it is the y value, so temperature will be here, and your number of ice cream will be here. So you have analyzed a lot, you got a lot of data. So suppose your data looks something like that. You have a lot of data. And by looking at this graph, you can see when the temperature is high, the ice cream sold, the number of ice cream sold is also high, correct? When the temperature is low, I mean when it's winter, the number of ice cream sold is very low. Uh, Suppose we are giving some random values over here. So on and so forth. By looking at this thing, you can see that there can be there that we can draw a line that goes through all of this data point, right? If we draw a line over here, that won't be the best fit line to the data points that are given here, correct? Then suppose we draw a line like this. That is also not the best fit line. The best fit line that we want is that the line that goes through all this data point. So suppose this is your best fit line, correct? This is your best fit line, and you got it by the values of ice number of ice cream and temperature. Now you want to predict that suppose yes, this is unreal, but yeah, suppose in 100 degrees Celsius, what will be the number of ice cream sold? You want to find that, but your data doesn't. Just a second, please. What is wrong with my graphics tab? Okay, so you don't have your target or label for 100 degrees Celsius. You have your label for 40 degrees Celsius. You have 30. You have 20. Suppose for 30 degrees Celsius, 10 number of ice cream is sold. Now you want to calculate. You want to predict how many ice cream will be sold for 100 degrees Celsius. So if we draw a line over here and suppose this is 60, so you can predict that, okay, when the temperature is 60 degree, maybe we will have our 60 ice cream sold. So you see, in supervised learning, the label or target is given, and this is your label or target, the number of ice cream, right? But in unsupervised learning, you won't be having this label. You will have some pattern, you will have some unlabeled data, just features, and from that feature, you will find some interesting pattern or interesting idea. You will tell your model, okay, so give me some interesting idea or to give me some interesting patterns. So that will be beneficial to your business or whatever the reason you're running your model for. Correct? So this was one example. Don't worry, we will go through a lot of example so that you can understand it nicely. So this example was for linear regression. Linear regression. Why? Because we have only one number of feature over here. So wx plus b. This is the line over here, best fit line. And we will get into all these things in the upcoming session. But today we will just getting the basic idea. So that was for linear regression. Let's move to another topic. Okay. Let's do this classical problem that we all talk about when we learn machine learning. That is the house versus price prediction. Actually, price versus house prediction, because price is at y variable, y axis, and house size is at this one. Okay, so suppose you want to buy a house for your family. Now, you want to know, okay, so I want to buy a house which will be 3,000 square feet. What will be the estimated price for that? Since you have no idea, since you have no idea about what will be the price, your model doesn't have any idea what will be the price for 3,000, it will create an algorithm, it will draw a best fit line, and then you will get some price for 3,000 taka. So similar case, a lot of data, draw a best fit line. You want to predict for 3,000, so you are getting the value for 3,000. You are getting the price for 3,000 that you are asking for. So in this case, don't you have your feature, and also you have your label, which is your price. You have some data point. which is given. Suppose the house size when it's 900 square feet, the price is let's say 50 lakh. Okay. Uh, you have a lot of data like that. By understanding this data, by running some models and some algorithms in this data, you are getting an estimated value which is 3000. So this is what actually machine learning do. Machine learning find patterns in your given data set, in your given value. Okay. So am I clear till this part? Is there anything that you don't understand you want me to repeat, or I should
No,
move
all
on?
good.
All right, all right. Okay, so I just said to you, right, that feature, there can be multiple feature. I told you. So in this case, we have seen examples where we have only one feature. Ice cream was, sorry, what, it was not ice cream, it was temperature. Temperature was one feature. We have house size. That is only one feature. You can also have multiple feature. Suppose the same example, your feature X1 is house size. Then you want to know some more data. You want to know some more thing about your house. So your another feature, that is number of room in that house. Then you want to know some more data. Another feature, suppose the height of ceiling, right? So you can have multiple features, and but your label would be one, which is your Y, and you're estimating the price over here. So that is also correct. And this type of problems will be solved by polynomial regression. You saw you had linear regression where you have only one feature, then you have polynomial regression where you have multiple feature. Then we have a lot of different algorithms as well, but since this is a very beginner friendly session, we will cover these topics in the upcoming session. Now let's quickly move to classification problem. Classification is also a problem that is solved, that is in supervised learning, and to solve classification problem we have to use these algorithms. Okay, and what is the main difference between regression and classification? In regression, you were predicting a number, you are predicting a continuous value, you can say a continuous value. The number can be discrete or continuous, but yes, you can have continuous number. But in classification, you are predicting a category. Let's say you are trying to find that whether you have given some features, you have given a petal length, you have given the number of leaves that that flower has, and you want to predict whether it is a rose or it is a lily. So in this case, you're not predicting values, you're predicting a category. In classification, what is the main takeaway from classification? That your label will always be in binary, such as 0 or 1. In let's say the 0 denotes yes, the 0 denotes the 1 denotes rose, the 0 denotes not rose. So when you have 0 and you have not rose, so you understand, okay, so your answer is lily. Then you can also see some other example. Okay, just let me quickly bring the slide board over here and let's talk about that. Okay, so now we're talking about classification, and it is also supervised learning. It is also under supervised learning, right? It is also supervised learning, and the main takeaway in classification is the label is either 0 or 1. yes or no. You don't have multiple label for that. You can only have this type of prediction. Suppose you show a picture and your algorithm tells you show you give some data set where you have some picture of dog, some picture of cat, and you want to find, okay, so you give a new input, suppose a dog picture, which is kindly different from the other dogs that you have fed in your model, and you want to see whether your model can predict if that is a dog or a cat. You know, you don't have a number for that. You can only have two options, either this or that, either this or that, dag, dog or cat, lily or tulip. Okay, let's talk about some examples so we can learn it more nicely. Suppose you want to in your input values you give a data set which is about name names of people in Asia, suppose. And we can see that mostly in Asian country, the girl's name has A in the last letter. Suppose my name, Rosa, I have A. So most girl have A in their last letter of their name. So now I want to I have given a data set which is names of people in Asia, and I want to test if my model can guess it correctly whether it is a male or female. I'm talking about gender classification using name. So suppose you have given a lot of data and okay. So okay. Okay, this shouldn't be male name. You might have different features. Whether it ends with the words ends with A or not. Then again the number of letter. And suppose this is how your graph looks like. Suppose in this case the the what's happening. Okay, let it be. X denotes female and 0 denotes male. So firstly what your model will do, it will be right. So your model will be going through all this data, and after some performance you will get this kind of data where you will see a decision boundary where it is dividing, it is giving you a decision line, or it is also known as threshold, if I'm correct. Yes. So this line differentiates between male, female, and male. Suppose you give a new name, let's take my name, Rosa, and you asked, Acha, whether this is a male or is it a female? And then your value somewhere lies somewhere between here. So you can easily tell, okay, so it is not this side of the boundary. It is that side of the boundary. So my input, which was my name, should be female. You see, you have only two options, either female or male. That's what I was saying, that in classification you have only two outputs. You can only have two labels. So that was one example. Let's have some other examples to make this thing more clear. Okay. Suppose in your feature or X, you have age and the size of tumor as your feature. And as your label, you want to predict either that is a malignant, either that tumor is malignant or not. You know what malignant means? Malignant means that that the tumor is cancerous. So you may have cancer, God forbid, uh, or you have another option which is not malignant. So you have only two options. So again, suppose for malignant we are symbolizing it as circle, and not malignant, for this we are symbolizing it as cross. So again, different data point for, okay, let's keep age over here. And you know, age and tumor both are feature over here, by the way, don't confuse, it's not label. It is it is x2, and tumor it is x1, two feature over here. And after performing your algorithm, your model, you have something like that. And it has again a decision boundary that is separating your malignant or and non-malignant. So if your input is in this side, you'll say okay, it is malignant. And suppose your input gives your result in this side, so you will say it is, what was it? It was not malignant. So you will have some sort of result in yes or no, 0 or 1, malignant or not malignant. Then another example.
May I add
Uh,
something?
yeah.
How this model creating that decision boundary?
Okay, so it is a long procedure. Okay, we will talk about this in the next session. It uses some algorithms. Like in this case, we were talking about what classification, right? So it may use naive Bayes theorem. There are different kind of model. Just let me show you. Where was I? You see, these algorithms or these models, it is done by these models. When you put your values in these models, it will give you some sort of answer. Regression is a problem. It is you can tell that it is a type of problem, and that problem is solved by these algorithms. Supervised learning, in supervised learning we have regression and classification, and using these algorithms or models we will solve that. And these have a pretty huge, we need to have some pretty huge discussion. So we will talk about that in the next sessions. So just stay tuned. Right. So yeah, this was your one example, which was for tumor and age, where your feature was tumor and age, and you were getting some prediction, your label, right? Move to another example. Guys, do you want to see some another example in classification, or should I move to the unsupervised learning? You want to see some more example so that your idea of classification is clear, or I should move to the next topic?
I think we should move to the next topic.
Okay, so let's talk about unsupervised learning then. Yes. The main difference between supervised learning and unsupervised learning is that word, which is unlabeled here. We won't be having any labeled data for our unsupervised learning. Our training data will be unlabeled, and there are different kind of unsupervised learning. Let's talk about clustering. Then we will talk about anomaly detection. Now let's talk about what kind of real life cases unsupervised learning solves. Suppose it is widely used in market segmentation, then movie recommendation, then finding the anomaly or anomaly detection. I mean detecting the fraud. Then you can also tell it is widely used in LLP, categorizing article in news, speech recognition, so on and so forth. Let's talk about that one by one. Yes, unsupervised learning, right? So, in unsupervised learning, our data will be unlabeled, so we don't have any values for y over here. It's only input in our data set, and we won't see any corresponding output. Just like in my example, I was going through different stores, and my input was the type of fabric that and its price, right? And my output was what kind of. Okay, I don't know why, but today my graphics tab is giving me big headache. Okay, so input was fabric size, or you can say type of fabric, because we can have multiple features, right? Multiple X types of fabric, and in output we were getting the prices for that fabric in different stores. But in this case, we won't have this part. We will be talking about only this part. And you see, this in unsupervised learning, what you basically do, suppose this is your model, you give some data to your model, and you tell your model that find some interesting pattern, find some interesting pattern, because you don't know that what exactly thing you are trying to find, right? And then it may give us some interesting pattern, and after getting that pattern we may draw some conclusion. Okay, we may draw some conclusion, or we may predict from that interesting insights. So basically in this part, you tell your model to give some interesting insight. Let's see some examples so it will be more clear. I told you that unsupervised learning is widely used in marketing segmentation. Okay, it is widely used in marketing segmentation, then object detection, so on and so forth. So uh, let's talk about marketing segmentation. Suppose as your input, as you don't have an output in your data, you give the you're running a business and you're selling t-shirts. Okay, you're running a business, you're selling t-shirt. You are giving weight and height of people, uh, of people that have already bought clothes from you, or some other people. This is your features, and you want to see, okay, what my model will give me. You want to see whether a model gives you some interesting pattern or not. Suppose for this you get some pattern like this, right? You get some pattern like this. Okay, so one thing, just like you asked that how these things are working internally. This algorithm use k means algorithm. This model is k means algorithm. So what it does, it repetitively runs some code that we will be talking next, and it creates cluster, right? It creates some cluster. That's why it is under clustered unsupervised learning. Yes, yes, correct. It is the algorithm or model, and it is after some repetitive code or some repetitive action, it is giving you this scenario that you are having some cluster in your data set. Now you have to find what does that cluster mean. Suppose in this part, since you're a business owner and you want your business to grow, right? So you have this intuition, this idea, okay, so maybe this number of people wear small size of t-shirt. This number of people uses medium. This number of people uses large. And you can tell whether the number of people using large, wearing large t-shirt is greater or not. I mean, you have some sort of idea about your data by looking at it. uh, but in the first place you didn't have any label, right? But you're still creating some prediction without using your label. So that is pretty much unsupervised learning. Then you have, suppose, let's talk about, let's talk about fraud detection. Fraud detection, suppose you are a business owner and you have a Facebook page, and whenever you post something, there is some people who comments free $1,000, do this, do that, and they're spamming your chat box. They're spamming, sorry, your comment box. Then you have some other words. Suppose, um, what other words is used in this type of thing? They use free. They use, um, you should only have your mobile phone and you will get do this, so you will get this very easily, blah blah blah. So suppose some words, in this case we're talking about a case scenario, we want to detect the fraud. In this case we are uh, we're taking the name of the id. No, name of the id wouldn't be a good example. The words that person use in the comment section. Then you're also taking another feature as their frequency, how frequently they're doing it. You know, these are some basic examples, but in real world you have some multiple features. Then you have to do feature scaling to get the best feature so that your model runs very well. Data cleaning and data pre-processing is very important. You may run a model that is very easy. You take input, you throw that input to your model, it will give some prediction, but it is very important to clean your data so that it gives a good prediction. So frequency words, we're just randomly taking it, but in real life scenario, it will be very different and pretty complicated, surely. So suppose after doing that, you're taking the users frequency of comment, users words, the words they're using in their comment. And you have some data like this. Suppose you have some data like this, and suppose you have few data that are very high in frequency. Also, the word is also very high. Suppose you have some data in some distinct position, and after running some algorithms, your anomaly detection algorithm, you will see some algorithm over there. You can predict, okay, so these are our normal customer, and these are the people who are actually spamming the comment section, who are actually fraud. So, by doing all these things, you can detect your fraud. And the fraud detection application is in supervised learning, since you don't have any uh, unlabeled, since your y is unlabeled. I mean, you don't have any y for this case. Suppose another example, if you go to another example, okay, so um, let's talk about some pictures. Suppose you have some picture as your input, picture of some trees, okay, picture of some trees, and you don't have any y, unlabeled data again, and you want to find something interesting within this data set, which is some pictures of trees. Now there might be some pictures where the tree is very tall, and there might be cases where the regular trees are like that. So in this case, again, you will get something like that. Your regular data lies very closely to each other, but your irregular data, which is different from the regular one, lies a little far away, so that you can detect, okay, so it has something interesting. Let's see what it has to tell us. And suppose in this case, your its feature is height of a tree, and what can we say, the something over here, okay. um you can also see unsupervised learning in Google News. What it does, you have only words, it actually picks out the words and differentiate it into different articles. So basically, categorizing categorizing article in news, in using article in news, because every day you are having thousands, millions of news, right? And if you don't use a efficient algorithm, how you will find the news is that you are searching for? And it is also similar to movie recommendation, or some recommendation that the business pages use. You want to buy a hat, then they analyze your data, and then they will give you some more ad of hat or whatever you want to buy. So almost this was about unsupervised learning. Guys, if you have any question, please ask me. Am I going too fast? I'm going too slow. If you have any question, please ask. Okay, I think we can move forward. Right. Now let's talk about reinforcement learning. Okay, so it is pretty different from the previous two learnings, to machine learning that we have just studied. It is pretty different. In reinforcement learning, what we actually do, we actually give feedback. It is a feedback based machine learning technique, and seeing the result of action, it will give you some reward or some punishment. Let me give you an interesting example. So suppose you have a stubborn child in your house, and whenever, just a second please, yes, suppose you have a stubborn child in your house, and whenever that kid doesn't listen to you, whenever that kid listens to you, you give you give her or him a chocolate. Suppose this kid is very mischievous. Whenever he or she is not listening to you, you are giving her or him a punishment. Let's say you're saying, no, don't do this, this is not good, this is not right. So what is actually happening here, this kid is actually being trained by getting some responses from the environment. And who is giving the reward or punishment? The agent is giving the reward or punishment. So in this case, an agent learns to behave in an environment by performing the action and getting rewards accordingly. And it doesn't use label data. So since it doesn't use label data, it learns by experience. So in this case, the experience is very important in reinforcement learning. Let's say another common example, that uh, you're trying to train your dog. You're trying to say that stand up. Let's say your dog's name is Coco. I don't know whether it's a good name or not. Stand up, Coco. If Coco stands, if Coco is sitting down, suppose this is, okay, I'm very bad at drawing. Let it be. Let it be. Suppose Coco is sitting. You're asking Coco to sit, and Coco is standing. You are saying such words, no, Coco, not this way. You're giving an action, you're giving an reaction on Coco's action. Suppose the dog is doing very well, the dog is listening to your words, he's sitting, and you're giving it treat. So after doing this for a while, the dog is reinforced to learn this behavior. After each time Coco makes a progress, you give her a treat. So finally, Coco can stand up whenever you say, Coco, stand up. So this was about reinforcement learning. It is heavily used in robotics, where you try to model your robots using the reward function, and this reward function gives you some sort of response that yes, it is doing good or it is doing bad. And after getting the response, you try to reinforce your robot, and after a while it may adopt the thing that you're trying to make it learn. Maybe it's doing good. So it was pretty much about the reinforcement learning. Okay, so workflow of machine learning usually, excuse me. Okay, so workflow of machine learning. Firstly, you define the problem, you understand the situation, you understand the scenario. Then you build the data set. How do you build the data set? You do surveys, you pick data from, suppose there are already a lot of data set in Kaggle. You can take data set from there, or you can build your data set. Then you train your model, train the model. How you can train it? We have already learned about some models, right? Linear regression, logistic regression, k-means. You train the model using that algorithms, and after that you evaluate the model. So what is evaluate mean? Evaluate means you are actually testing the model whether it's doing right or wrong, and how you are testing it. There are few terms like that: precision, recall, F1 score, loss, or mean absolute error. By looking at these values, you can understand whether your model is doing correct or not. But we will talk about this, evaluating the model later on in a large manner so that you can understand. And after that, you use the model, you deploy the model, and it is pretty much all about machine learning. So yeah, that was from my part. If you have any questions, please ask me. So yeah, that was from my part. And today we we actually we actually went through some basic examples, but in actual world, the data set, the features, the labels are much more complex to handle. So yes, we will try to look into those things in the next session. And if you have any questions, please ask me. And thanks a lot, guys, for your patience and time. Thanks a lot.